Beneath Antarctica lies a trench deeper than the Grand Canyon, rivers untouched by sunlight for over 15 million years, and ancient microbes. But sea levels could surge, flooding U.S. coastal cities within decades. Explorers thought bacteria resistant to all antibiotics may reawaken. So what happens if all of Antarctica's ice suddenly melts? Let's find out. Antarctica. It's not just another frozen wilderness at the edge of the world. Spanning over 5.5 million square miles, Antarctica is about 40% larger than all of Europe. To put it another way, it could cover the entire continental United States 1.5 times over. But size isn't its only claim to fame. What truly sets Antarctica apart is its sheer influence. Locked beneath its frozen surface lies more than 90% of the Earth's ice and nearly 70% of its fresh water supply. Without this vast, frozen reservoir, the systems that sustain modern life, from agriculture to weather, would collapse. Buried thousands of meters below are the Gamburtsev Mountains, a range taller than the Alps, hidden beneath layers of compacted ice. Beneath it lie ancient valleys, forgotten riverbeds, and deep canyons etched into the bedrock, remnants of a prehistoric world. And then there's Lake Vostok. This subglacial lake, sealed off beneath nearly 13,000 feet of ice, has been isolated from sunlight for at least 15 million years. Nearby, researchers have uncovered what could be a subglacial ocean, over 460,000 square miles of water, an area roughly equal to the size of the South China Sea. Some scientists speculate that in these isolated, high-pressure ecosystems, unique life forms could be evolving organisms unlike anything found elsewhere on Earth. But why does this matter for the rest of us? Antarctica plays a critical role in regulating Earth's temperature. Through a phenomenon known as the albedo effect, its ice reflects up to 80% of the sun's rays, helping keep global temperatures in check. Take away that reflective surface, and the darker ocean beneath would absorb far more heat, triggering a feedback loop of rising temperatures, melting ice, and escalating climate disruption. So, what if, instead of melting over centuries, all that ice disappeared in a matter of days? What long-buried landscapes would be exposed? What global disasters would unfold? Sea levels would surge by nearly 200 feet, enough to drown major coastal cities across every continent. The world map would be redrawn, and ecosystems would face unprecedented upheaval. This isn't science fiction. It's a worst-case scenario grounded in scientific fact. But Antarctica's towering ice sheets and underground lakes are only the beginning. Beneath that breathtaking expanse lies a far more dangerous threat, one that scientists grimly refer to as the Doomsday Glacier. Its official name is Thwaites Glacier. Thwaites is a critical part of West Antarctica's coastal barrier, but it's falling apart. Right now, as this video plays, the glacier is disintegrating. It releases over 50 billion metric tons of ice into the Southern Ocean every single year. That's equivalent to the combined weight of 137,000 Empire State Buildings sliding into the sea annually. This one glacier alone is already responsible for roughly 4% of the current global sea level rise. And what's most alarming, scientists no longer believe its collapse will take centuries. For years, projections pointed to the 23rd century. Then revised estimates brought that timeline down to just a few decades. Now, new research from the International Thwaites Glacier Collaboration suggests the tipping point could come much sooner, particularly if current warming trends continue unchecked. When that threshold is crossed, we won't be dealing with a slow melt. Instead, the collapse would be sudden and catastrophic. Within minutes, sea levels could surge by nearly 2 feet. Coastal cities across the globe would feel the impact almost immediately. San Francisco would be flooded. Miami? Gone. New Orleans? Completely underwater. These would no longer be scenes from simulations, they would be unfolding in real time. What makes Thwaites so unstable isn't just the surface melting. Beneath the glacier, a river of meltwater fueled by geothermal heat flows rapidly toward the ocean. This under-ice stream acts like a natural lubricant, weakening the glacier from below and accelerating its slide. As Thwaites shatters, nearby glaciers that once leaned on its mass for support begin to collapse as well. One by one, they detach and crumble into the ocean, unleashing an unstoppable surge of additional ice. And Thwaites is only the beginning. Once that first domino falls, the rest of West Antarctica's ice sheet becomes exponentially more vulnerable. What lies beneath the remaining ice, the secrets, the pressures, the ancient geological forces, is still being uncovered. Below the ice, it's not just cracks and pressure-built crevasses. There are entire rivers flowing through the dark, untouched by sunlight for thousands of years. What fuels these rivers isn't surface runoff or melting snow. Instead, they're heated from below by geothermal energy rising from the Earth's interior. They wind their way through ancient canyons carved millions of years before the first humans walked the Earth. And as scientists drill deeper, the discoveries become even more astonishing. Fossilized forests have been found, frozen beneath the ice sheet. These trees, now locked in permafrost, are remnants of a time when Antarctica was not frozen, but thriving. Roughly 34 million years ago, during the Eocene epoch, Antarctica was covered in dense, humid rainforest. Trees, flowering plants, and possibly even prehistoric animals lived here in a climate that supported life, not glaciers. The fossil record proves it. Antarctica was once green. But that's not the only unexpected form of life found beneath the ice. Near the base of the ice shelves, scientists have discovered strange, mobile sea anemones, unlike their stationary relatives in tropical waters. These Antarctic anemones burrow into the underside of the ice and slowly pulse through the freezing water. They drift, not anchored, as if searching in the dark for food or warmth in an environment where both are scarce. Even deeper still lies a feature few people have ever heard of, a hidden trench larger than the Grand Canyon. Stretching well over 600 miles in length and plunging nearly 2 miles deep, this ice-covered canyon has remained completely concealed beneath Antarctica's thick interior. It is one of the most isolated places on Earth, sealed off for millions of years, and possibly home to entire ecosystems unlike anything found in the oceans today. In these isolated ecosystems, life does not feed on sunlight or fresh nutrients. Instead, survival depends on decay, ancient bacteria, decomposing skeletons, and remnants of organisms from a much warmer Earth. These life forms have evolved in isolation behind walls of ice. But what happens when that ice melts? Could they adapt and spread? Could they outcompete modern species? Or could they trigger unforeseen biological consequences in an already stressed marine environment? Before we continue, I have a special 10-second request for all of you listening. If you can help me in any way, just press the notification bell and hit that subscribe button. It means the world. It really supports this channel. And if you do that for me, I promise my team and I will do everything we can to make this show even better for you. Deal? The moment Antarctica's ice disappears, the mystery ends, and the consequences become brutally clear. This isn't just about a frozen continent anymore. It's about every one of us. Global sea levels wouldn't just inch upward. They would surge by as much as 70 meters. At that scale, the damage is not theoretical, it's global and irreversible. Over 40% of the world's population, more than 3 billion people, currently live near a coastline. That's nearly half of humanity suddenly standing in harm's way. Major cities, New York, London, Shanghai, Mumbai, Tokyo, and Sydney, would all be submerged. Landmarks that have stood for centuries would vanish. Entire neighborhoods, cultures, and economies would disappear beneath a relentless rise in sea level. Now, here's a twist that catches many off guard. As Antarctica melts, the sea level near the continent would actually fall at first. Why? Because Antarctica's ice sheet is so massive, its gravity physically pulls the surrounding ocean toward it. When that gravitational grip weakens, the water redistributes. Sea levels near the South Pole drop slightly, while coastlines thousands of miles away drown. And the devastation doesn't end at the waterline. As low-lying land disappears, mass migration begins. But not in the tens of thousands, in the hundreds of millions, possibly even in the billions. Families were forced to abandon their homes. Nations are watching borders shift beneath their feet. New safe zones would emerge: Canada, Alaska, and the newly exposed regions in the Arctic, and even parts of Antarctica itself could become the last viable places to settle. Meanwhile, the world's economic backbone starts to buckle. Ports, the gateways for global trade, are wiped out. Coastal groundwater becomes contaminated by salt water, leaving millions without safe drinking water. Farmlands turn to salty marshes. Global food supplies are shrinking fast. As resources dwindle, tension rises. Conflict over habitable land and fresh water, once predicted as future risks, has now become a present-day crisis. Nations clash, governments destabilize, and the world economy spins into free fall. And as catastrophic as that sounds, there's still one more layer, something not just lurking in the rising seas but locked inside the ice itself. Buried within Antarctica's ancient layers are pathogens, microorganisms and viruses that have been dormant for millions of years. And once the ice melts, they don't stay buried. What happens when these ancient diseases re-enter a world completely unprepared to face them? We've seen how fast a virus can spread in a connected world. Now consider the biological wildcards thawing beneath our feet, released not by accident, but by the steady drumbeat of climate collapse. If Antarctica's ice disappears, rising seas won't be the only threat. Something older and far less understood could emerge: ancient microbes and viruses preserved in the ice for thousands, even millions of years. These pathogens, buried deep in permafrost and glaciers, haven't seen the surface since long before humans existed. And as the ice melts, they're beginning to reawaken. According to a report from the World Health Organization, microbes once believed extinct, some more than 750,000 years old, are now being recovered from polar regions. Several are linked to respiratory diseases and genetic sequences similar to those seen in conditions like cystic fibrosis. Others show resistance to nearly all known antibiotics, making them potential superbugs, with no immunity in the population and no existing treatment. This isn't theoretical. In 2016, a 12-year-old in Siberia passed away after inhaling anthrax spores released from thawed reindeer carcasses. As permafrost melted, long-dormant bacteria became active and dangerous. Now consider Antarctica, where scientists drill into ancient subglacial lakes. One sample could release a pathogen into the air. It may spread slowly at first, then cross continents through the jet stream or global travel. No vaccine, no early warning. Yet not every microbe trapped in the ice is harmful. Some produce enzymes that break down plastic or kill drug-resistant bacteria. These ancient organisms could lead to breakthroughs in medicine, materials, and biotechnology. One company, Geltech, is already advancing solutions. Their gel-based system delivers time-released, high-dose antibiotics designed to target infections resistant to standard drugs. As of 2025, the technology is moving toward FDA approval for global emergency use, especially for vulnerable populations. But as science works to contain the biological risk, another danger is accelerating: the disruption of Earth's ocean systems. Antarctica's ice does more than hold back water; it regulates planetary circulation. Once that balance breaks, ocean currents will shift, weather patterns will destabilize, and ecosystems, both marine and terrestrial, will face irreversible change. The threat beneath the ice isn't just biological or physical. It's systemic. And it's unfolding now. What do you think? Could ancient microbes become our greatest threat or our biggest breakthrough? Share your thoughts in the comments. Let's talk about the future we're unlocking. The collapse of Antarctica's ice doesn't just raise sea levels, it disrupts the entire system that stabilizes Earth's climate. Earth's oceans function like a massive conveyor belt. Near the poles, cold, salty water sinks, pulling warmer surface water from the equator. This deep circulation, known as thermohaline circulation, regulates global temperatures and drives major currents, including the Gulf Stream. But when Antarctic ice melts, it floods the ocean with fresh water, weakening this system. By 2025, scientists have confirmed that the Gulf Stream is already slowing. Without it, northern and western Europe may cool dramatically, even as the rest of the world heats up. Meanwhile, the tropics face extreme heat, droughts, and failed crops. Storm systems grow stronger. Hurricanes reach further inland. Once rare weather disasters become regular, climate chaos becomes the new normal. During the 2024 hurricane season, oceanographer Dr. Elias Monroe warned, "When we disrupt the oceans, we disrupt everything: food, weather, even civilization itself." And it gets worse. Melting Antarctic ice releases iron-rich nutrients, sparking enormous phytoplankton blooms. These microscopic algae feed the ocean's entire food chain and absorb carbon dioxide. But without ocean circulation to replenish nutrients, these blooms collapse, starving marine ecosystems from the base up. No plankton means no krill, no fish, no whales, seals, or seabirds. Fisheries collapse. And since over 3 billion people rely on seafood as a primary protein source, human hunger becomes inevitable. And this chain reaction doesn't stop here. As the ice melts, it unlocks one final threat, a powerful greenhouse gas feedback loop that could push Earth's temperature into dangerous territory. But the collapse of marine ecosystems is only the beginning. Because once Antarctica melts, it doesn't just drown cities or disrupt ocean currents, it begins to supercharge Earth's atmosphere. As glaciers release massive volumes of fresh water into the ocean, that fresh water forms a thin layer floating on top, a lens that's lighter and less salty than the seawater beneath. This layer interferes with one of the ocean's most important roles, absorbing carbon dioxide. Ordinarily, our oceans act as a carbon sponge, soaking up roughly 1/4 of the carbon dioxide released by human activity. But when that sponge gets sealed off, carbon dioxide builds up rapidly in the atmosphere, trapping even more heat. As ocean temperatures rise, decomposition in the deep sea accelerates. Microscopic fungi and bacteria begin breaking down dead marine organisms at a faster pace, releasing even more carbon dioxide and, critically, methane. These tiny decomposers function much like fungi in a forest, except their byproduct is a potent mix of greenhouse gases. Methane, in particular, is no joke. It is more than 80 times more powerful than carbon dioxide over a 20-year period. This chain reaction forms what scientists call a feedback loop. The warmer it gets, the more greenhouse gases are released. The more gases are released, the warmer it gets, cycling faster each year. And that's not the only source of runaway warming. In the Arctic and Antarctic regions, another trigger is thawing beneath our feet: permafrost. Permafrost is frozen soil, packed with ancient plant matter and microorganisms. As it thaws, it begins to rot. And when it rots, it releases methane in staggering quantities. Climate scientists warn that widespread permafrost thaw could raise global temperatures by between 5 and 10 degrees Celsius, enough to render entire regions of the planet uninhabitable. Not in centuries, in just a few decades. But there's still more hidden beneath the ice: ancient landscapes, untouched ecosystems, and perhaps even hints of a future where humans might one day try to survive, not despite Antarctica, but within it. The animals of Antarctica, survivors of the harshest conditions on Earth for millions of years, are now trapped in a climate spiral they can't escape. Take penguins. Iconic, resilient, and perfectly adapted for ice. But not for its disappearance. As ice shelves collapse, penguin colonies lose the stable ground they need to breed. Chicks are left stranded, exposed to predators or trapped in open water, unable to swim. According to the International Union for Conservation of Nature's 2025 Wildlife Climate Impact Report, emperor penguins could face functional extinction by the end of this century if current trends continue. That means their population may become too small to sustain itself in the wild. It doesn't stop there. Seals and whales, the giants of the Southern Ocean, depend on sea ice and on krill, the tiny crustaceans that anchor the Antarctic food web. But krill feed on phytoplankton, and phytoplankton depend on cold, nutrient-rich waters stirred by ocean currents beneath the ice. With that system collapsing, krill populations plummet. And with them, the species that feed on them, fish, birds, seals, whales, begin to vanish. It's not just decline. It's an ecological collapse. From microscopic plankton to the largest predators, the Southern Ocean begins to fall silent. In 2023, marine biologist Dr. Talia Angata returned to a nesting site once filled with thousands of Adelie penguins. She found fewer than 50. As the ice retreats, life begins to creep into places once buried under glaciers. Meltwater nourishes new plant life. Birds explore new territory. Microbes evolve. Entire ecosystems begin to form from the melt. But this raises a critical question. What kind of world will this new life inherit? A world regaining balance, or one still spiraling toward irreversible change? As wildlife vanishes or struggles to adapt, an unexpected possibility begins to surface. Because when the ice disappears, Antarctica doesn't vanish, it reappears. What lies beneath is a landmass larger than Australia, exposed for the first time in over 34 million years. Geological evidence confirms that during the Eocene epoch, this continent was a lush rainforest. Fossilized pollen, tree trunks, and sediment layers buried beneath the glaciers tell the story. Rivers once carved through fertile valleys, birds nested in forest canopies, and giant marsupials roamed alongside primitive whales. So the question now arises, could that world return? Some scientists believe that, given enough warming, Antarctica could once again support life, not just microbial or marine, but forests, grasslands, and animal populations. With time, even human settlement might become viable. Farmlands are spreading across newly thawed plains, cities rising along temperate rivers. The coldest, most remote continent transformed into a new frontier. But this is no longer theoretical. Discussions are already underway. Behind closed doors, governments, corporations, and private entities are quietly evaluating the future of Antarctic land. Right now, the continent is protected by the Antarctic Treaty System, which prohibits military use and mineral extraction. But treaties can be rewritten, and laws under pressure can be ignored. When that land becomes exposed and increasingly valuable, what happens next? Will we see a sustainable new chapter, or the beginning of a geopolitical struggle? The real question isn't whether we could settle this new land. It's whether we'll treat it as a chance to start responsibly or repeat the same patterns that brought us here in the first place. If Antarctica became inhabitable again, do you think humanity would treat it with care, or would we exploit it like every other frontier? Drop your honest thoughts in the comments. I'd love to hear your vision. And don't forget to subscribe and follow the channel to discover more interesting things. After everything we've explored, cities swallowed by floods, wildlife on the brink, ocean currents breaking down, and an ancient continent revealed beneath melting ice, one question remains. Could this really happen? The good news is, not exactly. Not all at once. A total collapse of Antarctica's ice sheet would likely take thousands of years, even under the worst-case climate projections. The continent holds over 25 million cubic kilometers of ice, far too vast to vanish overnight. But that's not the whole story. Parts of Antarctica are already showing signs of rapid destabilization. The most alarming example, the Thwaites Glacier. According to a 2025 report from the British Antarctic Survey, Thwaites is now losing more than 50 billion tons of ice every year. Its ice shelf, the section that acts as a dam holding back even more ice on land, is cracking apart faster than expected. Some researchers now warn that it could collapse within our lifetime, triggering a dramatic surge in sea levels within decades, not millennia. Could Thwaites start a domino effect? Could Earth's climate unravel faster than we predicted? The answer is, we don't fully know, and that uncertainty may be the most chilling fact of all. We've seen the science. We've traced the chain reactions. But what if the worst actually happened? What if all of Antarctica's ice melted completely? In this final scenario, the world is forever changed. First, the scale. A full Antarctic melt would raise sea levels by 70 meters. That's enough to drown every single coastal city on the planet. Nearly 3 billion lives would be lost. That's close to 40% of the global population, most of whom live near coastlines. Entire nations vanish beneath the sea. Bangladesh, the Netherlands, island states across the Pacific. Cities like New York, Venice, and Shanghai become submerged relics. The eastern seaboard of the United States, gone. Those who survive flee inland. But the disaster doesn't end at the shoreline. Salt water seeps into underground aquifers, contaminating drinking water for hundreds of millions. Farmlands are flooded. Soil turns saline. Crops fail. Global food production collapses. Famine spreads across continents. As resources disappear and billions are displaced, conflict erupts. Governments falter. Military alliances dissolve. New powers rise in mountainous regions and untouched highlands. What's left is a fractured map of survival. Some scientists call this the climate endgame, not the end of Earth, but the end of global civilization as we know it. Can we stop it? Can we change course before the water rises? What do you think? Can we still change course, or is the damage already done? If you enjoyed today's video, please give it a like, and don't forget to subscribe to the channel. Your support means a lot to us. Click on the video that appears on your screen right now. I hope you'll love this content. Comment below about the next topic you'd like to see featured on our channel. Thank you so much for watching, and we'll see you in the next video. Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.